students, let us start with the next module of this chapter, probability distribution. And in this module, we are going to learn problems based on E of x, that is mean, variance and standard deviation. So let us start with the given problem here. Calculate the expected value of the sum of two numbers obtained when two fair dice are rolled. So let us start with the solution. To start up with the solution, we require the sample space, and we all know that the sample space when two fair dice are rolled is as follows. Now here what we should understand is, if two dice are rolled, then the sum of the numbers on the uppermost faces can be from 2 to 12. This means when both the dice show 1 and 1, the minimum sum will be 2. And when both the dice show 6 and 6, the maximum sum will be 12. Now I need to write down the probability distribution table. So here I will write the values of xi as 2, 3, 4, 5, 6 and so on up to 12. Now let us try to write the probability for each of the values. So first of all, I require the sum as 2. Now when the sum is 2, when the outcome is 1, 1, so the probability is 1 upon 36. Now for sum 3, when the sum is 3, these are the following cases. So the probability is 2 upon 36. Now for sum equal to 4, the cases are as follows. So the probability is 3 upon 36. Now for sum 5, the probability will be simply equal to 4 upon 36 for the following cases. For sum equal to 6. Now when the sum is 6, these are the following cases. So the number is 5 elements, so the probability is 5 by 36. Now for sum equal to 7, the next case is for sum 7. These are the following outcomes. Therefore the probability is simply 6 upon 36. For sum 8, the elements are as follows, which are marked here, and the probability is 5 by 36. For sum equal to 9, the probability is as follows, which is 4 by 36. And so on for sum equal to 10, these are the following cases. The probability is 3 by 36. And for sum equal to 11, the probability is 2 upon 36. And the last value, that is for sum equal to 12, this is the only case. Therefore I can say that probability is 1 upon 36. So this table here is required probability distribution. Now moving further here, let us start with the actual part, that is expected value is summation xi into p of xi. The table which we have is as follows, which we obtained just now. Let us just substitute the values. That is, here the values will be 2 into 1 upon 36 plus 3 into 2 upon 36 plus 4 into 3 upon 36 plus 5 into 4 upon 36, 6 into 5 by 36 and so on. The elements will be up to 12 into 1 by 36, and we have to add all these elements. Now if you observe, 1 by 36 is common in all these. So taking 1 by 36 common, the remaining terms will be as follows: 2 plus 6 plus 12 plus 20 plus 30 plus 42 plus 40 plus 36 plus 30 plus 22 plus 12. Now on adding these elements, I get the value as 252 upon 36. Now on further simplification, this value turns out to be as 7. Therefore E of x is equal to 7. The expected value is 7. So now this is how we calculate expected value. Let us move further to the next example. P of x is given to us. Find mean and variance. Let us start with the solution here. When we write the table for x and p of x, the values of x are 1, 2, 3 and 4, and we will get the corresponding probabilities as k, 4k, 9k and 16k. When you substitute this as the function of PMF, this is a PMF, therefore I can say that the summation of probabilities will be equal to 1, which means the value for probabilities, that is k plus 4k plus 9k plus 16k, this value should be equal to 1. Now when you add the values here, the sum turns out to be as 30k and this value is equal to 1. Therefore we can say that k is 1 upon 30. So this is the value for k. Let us move further to find out the mean. Now to find out mean, that is E of x, we require summation of xi into p of xi. So this is the table which we have. From this we will substitute the values. The value will be 1 into k plus 2 into 4k plus 3 into 9k plus 4 into 16k. On adding these, the terms will be simply like this here: 100k, that is k plus 8k plus 27k plus 64k. Now the value of k is known to us, which is 1 by 30. So on substituting the value of k, the mean will be 100 upon 30, which is nothing but 10 by 3. Now moving further to the next part here, we require E of x square also to find out variance. So E of x square is given by the formula summation xi square into p of xi. This is the table. Now just substituting the values from the given table: 1 into k plus 4 into 4k plus 9 into 9k plus 16 into 16k. This value turns out to be as 354k. Substituting the value of k as 1 by 30, this term is 354 upon 30. Now on further simplification, this reduces to 59 by 5. Now in this part here, this is the value for E of x square. Moving further to find out variance, we know that variance is equal to E of x square minus E of x the whole square. Substituting the values which we have obtained, 59 by 5 minus 10 by 3 the whole square. This term gets converted to 59 by 5 minus 100 by 9. On further simplification, the value reduces to 531 minus 500 upon 45. This is nothing but 31 upon 45. So this is the required value for variance of x. Thank you.